average height is 64 inches, and the standard deviation is 2.8 inches. Question?
Does it matter that you only sample 25 guys and then 30 girls?
No, that's probably okay. It's okay that we have different sample sizes.
So would the data for the females be more precise because there's more?
Maybe. Not that's a little concern to us. So what we are looking for is what is the difference between the average height of a male and the average height of a female. So our answer is going to be in the vicinity of what value? It's going to be, what would be an approximate answer? Okay. So based on our data, it looks like the average height difference is about 5.5 inches. So our answer is going to be the difference between the average height of a male and the average height of a female is about 5.5 inches, give or take something else. Give or take something. Does that seem reasonable? Okay. So we're not asking how tall is the average male and how tall is the average female. We're asking what is the difference between the average male and the average female. Okay? That's what a confidence interval for the difference between population means is talking about. We're not talking about the individual mean, or this group's mean and this group's mean. We're just talking about the difference between them. Okay, so our answer will look something like difference between average height of males and average height of females is 5.5 inches, give or take. Okay. So I said in the problem you should identify all of these bits. So let's say we want to make a 95% confidence interval. Okay. So let's identify all 6 bits of information. What is x bar 1? Let's say sample 1 will be the males. Okay. So x bar 1 is 69.5. S1 is 3. N1 is 25. Okay. Sample 2 will be the females. Okay, so what is x bar 2?
64.
64. And S2, 2.8. And N2,
30.
30. And our confidence level?
Still
95%. Okay. So make sure that when you read a problem, you can pick out all of this information. Okay, so now for the actual formula. Confidence interval for mu1 minus mu2. In the center, x bar 1 minus x bar 2. I put parentheses around them, but just to indicate that that's goes in our middle. Plus or minus t star times, and the standard error is an ugly thing, nothing we can do about it. S1 squared over N1, S2 squared over N2.
So are we trying to find that mu1 is greater than mu2 or is it equal to? In this question?
That can be answered with our confidence interval at the end, yes.
But if we were before, just by looking at a question, you won't be able to understand that?
So in our case, in this simple example, we can probably say yes, we know that men are taller than women.
So you would say that mu1 is greater than mu2.
Yeah, but that's not the goal. Okay, so this is the formula to find the confidence interval for mu1 minus mu2. This is the center. This is our critical value. And this here is our standard error. Alright, so let's plug in our values. X bar 1 is 69.5. Subtract off X bar 2, 64. Plus or minus, we'll talk about T star in a moment here. Standard error is S1 squared, so I put 3 squared over 25 plus S2 squared, 2.8 squared divided by 30. For the critical value, we need our degrees of freedom and our confidence level. Degrees of freedom is still n minus 1, but which n do we use? We have n1 and n2. Well, we use the smaller n. So in our case, we would use 25, because I've got 25 and I've got 30. So I'm going to use the smaller n, 25. And so how many degrees of freedom do I have? I have 24 degrees of freedom. Sorry. So degrees of freedom is n minus 1, but we use the smaller n. So in our case, I have my two n's are 25 and 30. I'm going to use 25. 25 minus 1 is 24. I have 24 degrees of freedom, 95% confidence. What is my critical value?
2.064.
2.064. How did I get what?
25 minus 1.
I have two n's. I've got 25 and I've got 30. I'm going to use the smaller n. So I use 25. I do n minus 1. And I look that up in the table. So with 24 degrees of freedom and 95% confidence, my critical value is 2.064. Can we find that value on the table? Okay. Okay. So punch this into your calculator. Let's make sure we get the same value. The square root of this whole thing. I'm getting 0.788.
We just put 0.79.
0.79? That's close enough. Are we able to get 0.788? Yes? No?
Yes.
No? I see it. No. So let's just make sure. Okay, so the value numbers you should punch into your calculator are 3, and there's probably a square button on your calculator
But,
that looks like this.
but if you have,
Yeah, that's probably. Yeah, you got a square button right there. So you do 3 squared, divide sign, 25, plus 2.8, square button, divide sign, 30, and then hit equals, and then hit square root button, answer, equals. And you should get 0.788. Yes, good. This is just for those who had trouble with their calculators. If you did not have trouble with your calculators, you do not have to follow these. Alright, you guys settle down now. Someone's asking a question. Okay, go on. What is it's mu1 minus mu2, what is?
That's the hypothesis.
There's no hypothesis, we're just making a
Obviously, what is that?
So my confidence interval ends up becoming 5.5 plus or minus 1.63. Is that part okay? Okay. So I just want to make sure everyone's able to get 0.788. You multiply that by 2.064, and we have 5.5 plus or minus 1.63. So the original question is, what is the difference between the average height of a male and the average height of a female? So our answer is the difference between the average height of a male and the average height of females is 5.5 inches, give or take 1.63 inches. Or we can say, if I'm sorry? Yeah, so I do the plus minus, okay? So I do 5.5 plus 1.63 and I get 7.13, and I do 5.5 minus 1.63 and I get 3.87. So I can say the difference between the average height of males and the average height of females is 5.5, give or take 1.63 inches, or I can say I am 95% confident that the average height of males is between 3.87 inches and 7.13 inches taller than the average height of females. So when we get our confidence interval to look like this, we say I am 95% confident that the average height of males is between 3.87 inches and 7.13 inches taller than the average height of females.
So this is a two-sample t-test, right?
No, this is a confidence interval for mu1 minus mu2. Confidence interval based on 2 samples. There's no t-test yet. We have not done hypothesis testing. Question, yes?
I think I did something wrong because I took it 1.63.
I did 0.788 times 2.064.
Oh.
So we can just write either or on a test surface, right?
Yeah, this is probably the preferred form. Okay. Okay. Huh? We can round, but I think this is rounded enough. I've already done some rounding down to 2 decimals. Yeah, when you're dealing with means, you should probably keep at least 2 decimal points, or 2 decimal points. And when you're dealing with proportions, I would say keep 4 decimal points. Okay, so if somebody says, do we have evidence that the average height of males is higher than the average height of females, or is that? Or if someone says, do we have evidence that there's a difference between the average height of males and females? You would say, yes. And why? Okay, so do we have evidence that there's a difference between the average height of males and females? Okay, we would say yes. 0 is not within our interval. Okay, if 0 were inside the interval, then we would not have evidence of a difference. Okay, 0 is not between the ends of our interval. We have evidence that the average height of males is higher than the average height of females. Question?
Where does 0 come from? Or what does that have to do with
If there was no difference between the average height of males and females, what would the difference be?
Oh.
The difference would be 0.
Okay.
That's what we're looking for 0. Yes? Never mind. Okay, so with this one I'm willing to do a problem for you guys to try out. Okay? But I have to work relatively quickly just because we still got a lot to cover. So I'm going to leave that up. Question?
Yeah, no, yeah, they're trying to find a confidence interval between the average height of males and females.
Yes.
And you're trying to solve for a confidence interval for mu1 minus mu2, right?
Yes.
What is mu1 minus mu2?
mu1?
Yeah.
It's the difference. So mu1 is the mean height of males.
Okay.
mu2 is the mean height of females.
Is that between the mean height of males and females? Is that minus mean height? That looks like a minus sign.
Yes, that's the minus sign.
Okay.
So it's the difference.
So because you're gonna get the male's height and the females and subtract them, you get the average. I mean the difference.
Right.
Okay.
So it's kind of like, how much taller is the average male than the average female?
So you get to subtract them.
Okay. Or we could say, if we're talking about income, we'll say, what is the average wage of an American? What's the average wage of a German person? And we can say, what's the difference between the average wage of Americans and the average wage of Germans? Right? Whatever. That would be mu1 minus mu2. Okay, so let's say we're going to do a problem. We'll say, what is the difference between the average IQ of males and the average IQ of females. Okay, so you measure the IQ of, let's say, 35 males. The average IQ is 97 points with standard deviation of 17 points. Say sample of 27 females, average IQ is 102, and standard deviation of 15. Okay, I will say make a 90% confidence interval. So go ahead and take some time to do that. After you make a confidence interval, make sure you write out a statement that says, I am 90% confident, etc., etc., etc.